Hi. We'll look at binomial expansions, which comes in Core 2 at AS, and following on from our earlier video, when we looked at the general rule, a plus b all squared is a squared plus b squared at the end plus twice the product of the two. And now we're going to look at how we use it. Look at question 1. So the plus 9, the 9 represents the b, and a is 5x. So the expansion must be 25x squared plus 81, and then the middle term is twice the product of the two. 5x times 9 is 45x, double it, 90x. Right, I'm just going to give you a few minutes to finish though. Oh, let's go through question 2. Now the way we do this one is we rewrite it as 100 plus 5 all squared. So here 100 is fulfilling the taking the role of A, and 5 that of B. So the expansion is 100 squared is 10,000, 5 squared 25, and then in the middle we've got twice the product of those two. 100 times 5 is 500, double that, 1,000, and because they're all numbers we can simplify that as 1,125. Right, question 3. Let's go through this. Here, 2x is our A, and minus 5 is our B. So what do we get? We get 2x all squared, 4x squared. We get minus 5 all squared, plus 25. Then we get twice the product of the two. So 2x times minus 5 is minus 10x. Double it, minus 20x. Now, who in the audience got 4x squared minus 20x plus 25? What do you mean I wrote the question wrong? Hang on. Hi, welcome back. We're now going to look at binomial expansions. We're going to look at beyond squaring. We're going to look at to the power 3, 4, and then a general rule. Right. Let's have a look. What about a plus b all to the power 3? Now remember, a can stand for any number or anything else that can stand for a number. So for instance, it could stand for the letter x or the letter y, which stands for a number. What is it when it's cubed? Well, it's times itself and then times itself once more. Now we already know that these two multiplied together gives us a squared plus 2ab plus b squared. So we're going to multiply that by a plus b. Now, topping and tailing, so I don't forget anything, I've got to do 6 algebraic multiplications, working from right to left. A squared times a gives me a cubed. A times 2ab is plus 2a squared b. A times plus b squared is plus ab squared. Now I'm going to multiply by the b. B times a squared is plus a squared b. Notice alphabetically. Put them in order alphabetically. B times 2ab is plus 2ab squared. And plus b times plus b squared is plus b cubed. Now here's why we put them in order. We're looking for like terms to simplify it. A squared b's, any other a squared b's? Yes, there is. We've got these here and these here. What about the other two terms? Well, if we look, they contain both the same letters and the letters are all to the same power. So we've got some other terms we can simplify here. The ab squareds. And when we simplify those, we get a cubed plus 3a squared b plus the ones in light blue 3ab squared plus b cubed. Notice this. I've put them in descending order of powers of the first letter, which was A. If you want, it doesn't like there's any A here, but it's actually A to the power naught, which of course, as we know, anything to the power naught is 1. So if you want to see it, we've got A to the power 3, A to the power 2, A to the power 1, A to the power 0 going down. And if we want to look at it from the point of view of B, we've got B cubed at the end, B squared just for the end, B to the power 1, and here we could think of it as B to the power naught. Right, now we're just going to do one more expansion. We're going to look at A plus B all to the power 4. I just worked out that. A plus B times A plus B times A plus B, in other words, A plus B all cubed. I worked out that it is A cubed plus 3A squared B plus 3AB squared plus B cubed. So all I've got to do to work out what it is when I expand A plus B to the power 4 is multiply the answer for A plus B to the power 3 times A plus B. Now I don't want to miss anything, so I'm going to be systematic and top and tail. Right, let's go through this then. A times A cubed, A to the power 4. A times 3A squared B is 3A cubed B. A times 3AB squared is 3A squared B squared. A times plus B cubed is AB cubed. Now it looks like I'm going to run out of space here, so I'm going to start what I get when I multiply B underneath. So B times A cubed is A cubed B. B times 3A squared B is 3A squared B squared. B times 3AB squared is 3AB cubed. And then B times B cubed is B to the power 4. And don't worry, that's as far as we're going to expand this. Now, what we have to do is see if we can simplify it. Let's have a look. Any more A cubed B's? So it's got to have A cubed and B. Oh, here we are. What about A squared B's? A squared B squares. Oh, here we are. And there's sort of symmetry about this. I'm guessing that these two, yes, I guess correctly, have the same letters all to the same power. So simplifying it, I get A to the power 4 plus 4 A cubed B plus, these ones here in the middle, 6 A squared B squared plus 4 A B cubed plus B to the power 4. Right, now, I know this is a lengthy one. Let's just bring all these results together and see if we can try to work out a general rule. We're not going to prove it, we're just going to see if we can find out a general rule. we're going to do is we're going to try and hypothesize or conjecture or guess what this might be. And then we're going to check if our conjecture is correct. Any ideas then in the audience? What would be the first term were I to expand that? 8 to the power 5, yeah. And what would be the last term? B to the power 5. Now, the interesting bit. What is my second term and my last but one, my penultimate term, likely to be?
5a to the power of 4.
Yeah.
B.
B to the power
Of 1.
of 1, yeah. And here we'd have very similar. What do you reckon it would be? Any ideas? This is the one just before B to the power 5.
So 5a to the power 1 is 5.
Good. Now, the interesting bit, what's going to happen in between? Well, just before we go through this, when we squared it, we had a total of 3 terms. When we raised it to the power of 3, we had a total of 4 terms. When we had it raised to the power of 4, we had 1, 2, 3, 4, 5 terms. So it suggests that when we raise to the power of 5, it's 6 terms. So we've got 2 more terms in between. Let's forget the number in front, the coefficient. Can anybody tell me what the combination of A's and B's will be here? This one here. What will be the power of A?
3.
8 to the power of 3. And B will be to the power of? And here, what would be the powers of A and B? 2 and 3. So all we need to do now is to find out what those be. Because I think we've spotted the rule. The power of A is the same as the power of the bracket you're expanding, and then it goes down by 1 each time, so that you end up with it not appearing. In other words, it's hidden as A to the power 0, which is 1. And similarly, from the right, your powers of the second term are the same as the power you're raising it to, and they go down from the right. And saying you've got that hidden B to the power 0. Now, all we've got to do is try and work out what the coefficient is of these 2 terms. And we can find it by looking at the coefficients above. This one will be 10. And this one will be 10. How? Well, there's a triangle formed here. If I was to get them right. Anyway, I'll stop the show now. Actually, no, because I know it's a bit long. I'll have to edit it. Basically, if we look at the coefficients of each of the terms, we get the following. These are the coefficients. That's for it squared. When it's on its own, it will be just 1. When it's to the power 1, beg your pardon, it's 1 and 1. So this is when the power is 1. That's when it's squared. When the power of the bracket is 3, we get 1, 3, 3, and 1. When the power of the bracket is 4, we got 1, 4, 6, 4, and 1. And we saw that when we raised it to the power 5, we got 1 and 1 at the end. We got 5 here and 5 here. And to find the other 2, well, we look at the 2 sort of above. So it's going to be 10 and 10. Which suggests now, if we were to say 6, we would get 1, 6, 6, 1. And then our coefficients would be those 2, 15, those 2, 15, and then in the middle 20, and so on. And we can use Pascal's triangle to work out the coefficients. We know a rule for working out the powers and the combination of the letters, and we've now got a rule for working out the indices. So we'll stop there.